Let me share my screen first. Okay. Can you see my screen?
Yes, sir.
Okay. So this was the last assignment that I gave yesterday. Any of you tried to solve this? No one? Okay, so I'll give you the quick solution for it, but you have to try it on your own for the detailed solution. At least you should have tried, like there was a full 24 hours time with you. Okay, so the question is very much like last class we discussed about the return wind speed, if you remember. Um, so on a particular return period, what is the wind speed? That is the question is basically trying to ask you. Okay, so in that question you need to find out what is this V max. Okay, and or that is same thing VT in a particular return time. Okay, so you need to use this equation number 9. So let me tell you step by step how you need to do. So there are this is the whole set of data starting from 1952 to 1998. So these data are orderly in the means mentioned in the consecutive yearly manner. Okay. But in some cases you might not see the data is available in every year. Okay, so like here you can see that the data are available almost every year, but there might be some years there could be a question like some data are not there in a particular year. So you don't have to worry for that. What you need to do is you need to rearrange. The very first thing is rearrange this wind speed in a orderly manner or increasing order. Okay, so starting for the smallest, you need to go for the largest one. Okay, so irrespective of the year, all right. So this year doesn't matter now. So first, what you need to do is step one. You need to rearrange the wind speed, observed wind speed, in an increasing manner. Okay, so starting from 23.7, which you can see that corresponds to this particular year, 1967. Okay, so then you same way you arrange this. The total number of years available with us is 47. So some cases also you may notice that the two data are same, or any 2 years you will get a consecutive or the same wind speed. So for example here you see that 6 and 7. So you cannot skip this data. Okay, so you need to take this data set also take into account. All right, so for example here also 25.7. So this is the whole data set, and similar numbers if you observe, you cannot skip it, you just need to take it into account. All right, and so this is first thing is to rank them or arrange them in an increasing manner. Then using these two data, um, or rather only this increasing order data, you can plot them on a XY plot. Okay, so if the data sets are so large, like 47 or 50 around that data, so you need to use Excel, or if you're doing in the exam, if it is going to be offline, then the graph papers will be also given to you. So otherwise you just need to take use of Excel, Microsoft Excel. Okay, so here, so on the y-axis, this corresponds to the wind speed, and on the third column, I have calculated the reduced variate or the Gumbel variate. So which is basically your this particular term. Like yesterday, if you remember, we have defined this m by m plus 1, that is a probability of certain wind speed exceedance. Okay, so m by m plus 1, and taking the log or logarithmic of that is basically your Gumbel variate or reduced variate. and you see that term is also there in your equation. Okay, so that is what you are trying to do. You rearrange the wind speed and calculate this particular value, and this will be 1 to 1, right? For particular wind speed, you will get one value of the reduced variate. So 1 to 1 correspondence, and so you can get this XY plot. Okay, and this need not be a log scale, because you see that this is like XY or linear approximation, or this is basically y equals to mx plus c in that format. Okay, so this you can consider as your x-axis, and this is your y-axis. Okay, and the slope as well as your intercept you can find out. So once you plot these data points on the graph, you can then do a best fit. Okay, so that a particular line which is taking into account all this data point in a suitable manner, or a best fit you need to do, and from that best fit you can find out what is the slope of the line and as well as where it intercepts on the y-axis. Okay, so that will give you your beta value, the intercept, and the slope will give you 1 by alpha. Okay, so once you know this thing, then based on the question, you can actually substitute the information. So beta you can derive, 1 by alpha also you can derive from this. Then your question was for the 20 years time, 50 years time, 100 years time, and 200 years time, right? So you need to substitute t value respectively. Okay, so in one case it will be 20, the case 50, 100, like the question said. So here a set of return period is given to you, like which are calculated using this equation based on the alpha and beta obtained from here. Okay, so basically your beta is 27.81, alpha 1 by alpha is this much. Okay, and if you substitute, you'll get the return speed. All right. So this is one of the question that you may expect. Okay, something in the similar manner. But in your exam, I will not give this large data set. There may be few or a limited number of data set. It will not be so large because it will take time to rearrange them. Okay, it is not so easy to rearrange them. So it's a time consuming. So you don't expect to have so large data set. All right. Any question? Okay. If no question, so before I go to the next chapter, I would like to find out when all of you are available for the test. So this is not a surprise test. This is a planned test. So when can we have the test? So the test will be like MCQ plus some subjective type question together, and maybe for 1 hour, 1 to 1.5 hour maximum.
Sir, preferably a class time.
Preferably in the class time.
Yes, sir.
We don't have any other
Yes.
time slot. I mean, in the daytime. See, if I take, I can take during the class time, but we will have to, to cover up the content. Maybe I need to take extra classes towards the end. So,
Then days best, sir.
which day? Sorry, I could not hear you. What about in the evening, like let's say Tuesday evening? Is it okay?
Yes, sir.
Tuesday afternoon, I'm fine.
Sir, few of us have classes till 8.
Till 8. Okay, so Wednesday we have class. So I was thinking before the class at least, or we can go to the Wednesday if you all of you are also fine. Wednesday then 7 or 8 in the evening. Wednesday 7 o'clock.
Sir.
Wednesday you have class till 7. Someone said.
Yes, sir.
Yes, sir.
8. If we start from 8. Is it okay? Or
Sir, I'm Sadev. Sir, my quarantine period is ending on Wednesday, so I have to shift my entire my actual
okay.
room. But the room is closed since last 7 months. So I don't know how long it would take me to rearrange the stuff.
Okay, so then why don't you stay for one more day there?
Yeah, that
Don't
could also be done.
is that possible? Like, anyways,
Because
how is your health? Did you get any I mean any
no,
symptoms or
sir,
so?
no, sir, I'm all good.
Okay, that is nice to hear. So you see, if you can manage to stay there for one extra day, that will be okay. And if it is
Sir, what
convenient,
about the weekend?
what about the
A weekend, let's say a Saturday.
Saturday? Is it okay with everyone?
I think it'd be preferable to keep it on a weekday. Evening is fine.
Saturday we have a lot of different works to do.
Yeah, that is what I thought. Unless it is very necessary, don't want to. Like Saturday, you guys can spend your own time, or otherwise can read about the lectures, previous ones. And it is not so urgent. Like we just need to go to the Saturdays. So far, like it is just the beginning of the semester, so that's why. So let's keep it to this Wednesday. I mean the coming Wednesday, 8 o'clock. So it is agreeable to all of you. I'll just drop a message also in
I'm
the.
having one test on Wednesday, not at that time, but that day I'll be having. If it is on Wednesday, I'll be having two tests on that day.
What time you have the first test?
That's a placement test.
In the mornings.
It's a placement test.
No, no, sir. A subject one on entrepreneurship subject class test.
I have one placement test, a test as well.
Okay, so this thing will continue like that. So I think let's keep it on Wednesday. Okay, so those who have the test, they need to spend more time to prepare probably. And since like today is Thursday, you get 1 week time to read this whole thing. We can preferably go to Thursday also if it is too. I mean, few of you have test. You are telling. In other case, like we can go to the next Thursday, 8 o'clock. Is that okay?
Fine for me, sir.
Okay.
Yes, sir, that is
Thursday.
fine.
Okay, Thursday 8 p.m. Then Thursday is what day it is? That is 4th of February. Okay.
Okay, sir.
Okay. All right. So the test will be for anyone speaking?
Hello.
Yes.
What?
Who
You
is
meant 8
speaking? I cannot.
a.m.
8 p.m. 8 p.m. Thursday.
Okay. Okay.
Okay. All right. So next, about the term paper, I think I'm still finalizing that because I did not get much time yesterday. So probably tomorrow I will try to share the topics. Otherwise, I'll just drop messages on the chat box of this group. And what I can generally say, like all of you know how to use Fluent CFD software, ANSYS Fluent, and do you have access to that?
Sir, we know how to use it, but we do not have access to it.
You
Yes,
don't
sir.
have
Same
access.
problem.
Let's say, only a few of us who are working on BTP or MTP have VPN access given by our professors. And even after that, it's very tough to use ANSYS because the VPN keeps disconnecting and the software will simply stop in between.
Yeah, I was thinking about that fact also. So the assignment or the term paper, what I am going to give, it will be mostly on the review kind of thing. Okay. Those who can make some simulation on their own, very simplistic model, and you need to justify why you are going to use such simplistic model. That will be like preferable if you can have your own work apart from just reviewing others' work. Okay. But at the same time, that weightage will not be too much because since all of you are not having access to the software, but whoever tries, at least some benefit, some extra weightage will be given to the person. Okay. Then the otherwise, like if your work is, I mean, the summary of the work, how you present and how much you have the content, that also carries different type of weightage. Okay, so this we will evaluate after I give the topics, maybe tomorrow. We will have the evaluation in 2 weeks time, the first evaluation. Like we will fix a time and there's few groups will present their work, then subsequently the remaining groups, they will present their work, and the presentation may be, let's say, 2 weeks basis, right? So 15 to 20 minutes. Please try to stick to that. I saw last time like it can extend up to 40 minutes also. So we will keep it about 20 minutes presentation. Okay. In 2 weeks time. So every 2 weeks we will have evaluation. So roughly 3 to 4 evaluation on your progress, like how much. So these will be like mostly your review work, how many papers you are reading and what kind of, and it should be a continuous one. For example, like let me give you an example. Like if there is one topic is like aerodynamics of rail or bridge. Okay, so bridge construction, there are several bridge. So what are the aerodynamics factor they consider? This could be someone can investigate, and there are different experiments they do. There are different numerical simulation they do. So some observation from that, like what are the wind condition, how it affects. So you can find several works on it. Okay, so every 2 weeks we will try to see how much you have read on this particular area, and in the next 2 weeks time you need to continue on that. Okay, it is going to be like up to the end of your semester, and it will be a continuous progress. Okay, and the evaluation will be also in that way. So we're not going to change the topic. On the same topic you may read new work and present it. Okay, and any question? So this is clear, I suppose. Okay, so let me share the next slide. Okay, so the next chapter what we are going to discuss is atmospheric boundary layer. So this again we are.
Sir, what will be the syllabus of the test? Only chapter 1 or
chapter
till...
1, chapter 1, only chapter 1. So whatever we are teaching, I mean, so we are studying now, that we are, I mean, I'm not going to include that. Okay, so only chapter 1. So atmospheric boundary layer is the next chapter. It again deals with atmosphere in general. Okay, we are not yet seeing the application of the wind or wind energy harvesting, those which will be more interesting from the industrial viewpoint. We are still studying about the wind. Okay, so to begin with, let's say what is boundary layer. Okay, boundary layer, I think most of you might have studied this during your fluid mechanics or some preliminary course of the aerodynamics, for example, introduction to aerodynamics. So boundary layer is a viscous layer which is seen above the solid surface or above any flat plate kind of scenario, above the solid surface, where you have these viscous effects are dominant. Okay, so what do you mean by the viscous effect? So viscous effects means your viscous stresses. Okay, so viscous stress terms are dominant. So what happens, why it is so? Basically on the solid surface, the fluid will tends to follow the exact velocity of the solid. Okay, so for example, if this particular solid is stationary, here if you can see that if this particular solid is stationary, then the fluid velocity on the solid surface will be 0. and it will gradually increase as you go high. Okay, so let's say that at the beginning the fluid is moving at a uniform velocity u, but when it encounters this solid surface, its velocity, the nearby fluid or the adjacent fluid to the solid surface will have the same velocity as the solid. Okay, so that means it will be 0 here, and gradually it increases and it attains a value which is very close to the your free stream velocity, okay, which is maybe 99% of your free stream velocity. So beyond that, we don't say there is there is any effect of the solid surface, and that can be considered as your free stream. Okay, so in between this region, okay, so where you have been seeing the velocity gradient, and which occurs because of the presence of this solid surface, you basically name that region as your boundary layer. Okay, so boundary layer is the region which is generally seen next to the solid surface where you have viscous effect predominant. Okay, then up to certain height, generally you define another term, boundary layer thickness. So where your velocity reaches to 99% of your free stream velocity. Okay, so this is not only seen in the external flow scenario, this also you see in the internal flow scenario. So what is the difference between external and internal flow? Can someone tell me? What do you mean by external flow? What do you mean by internal flow?
So external flow is like you have like a bottle immersed in a fluid and the flow is moving around it, whereas internal flow is like flow through a pipe. It's like flow surrounded by a solid.
Oh, flow of, okay, yes. So flow, if like initially I thought you were talking about the bottle and flowing, the fluid is flowing through in the bottle. Okay, no. So if the flow is around the bottle, okay, externally, so that is external flow. When the flow is actually happening externally to the solid surface. Okay. So in this case, for example, if it is happening above the flat plate, and if the flow is happening in an internal manner, like in the pipe flow, as you have said, yes, that is an internal flow scenario. Okay, so do we get the boundary layer in both the case, or it is only limited to the external flow?
So boundary layers are universal phenomenon. They'll occur in internal as well as external flows.
That's correct. Okay, so boundary layer, wherever you have a surface, the fluid is going to the fluid velocity or adjacent to the surface will be same as the surface velocity. So boundary layer will be seen both in external and internal flows. All right. So something, when you come to the atmosphere, you know that we have an Earth surface. Okay, so Earth surface is kind of solid surface, you can assume, and in the same manner, since you see that the wind is not stationary, rather it is always in motion. So because of the interaction with the Earth surface, there will be development of a boundary layer. Okay, and this characteristics of this boundary layer is like it is not laminar. It is a turbulent scenario, whereas you might have studied in your lab scale experiments and all. Generally, in the lab, we try to do experiments with the laminar kind of boundary layer, and in certain cases, we do also, of course, turbulent boundary layer. So in general, the atmosphere has a lot of turbulence in it, so the boundary layer is never be laminar. Okay, so it is always turbulent, and the turbulent intensity varies with the roughness present on the Earth surface in that particular location. Okay, so generally, like already I have defined why the boundary layer is developed, like because of the presence of the Earth surface, and that resists the motion of the wind. Okay, and that resistance comes because of different roughness element. For example, you can have trees or forest. You can have urban forests, so-called the sky-raised buildings, or any industrial settings. Okay, or many other things which can contribute to the contributes as a roughness element. Okay, so because of that roughness element, the wind flow is resisted, and that gives rise to different type of boundary layer formation. Okay. Sometimes this atmospheric boundary layer is also called as planetary boundary layer, PBL, or just boundary layer. Okay, so the abbreviation for that is atmospheric boundary layer, ABL. Okay, so that is what I also forgot to mention before. So it is ABL, means atmospheric boundary layer, and it is otherwise also called as planetary boundary layer or simply boundary layer. Okay, so in the boundary layer, basically you see all those fluctuation of the physical quantities. For example, temperature, moisture, wind speed, all these physical quantities, they have lot of fluctuations in this boundary layer. Okay, so above the boundary layer, you can find more or less the situation is kind of steady. Okay, so the amount of fluctuation is not that significant, whereas inside boundary layer, the fluctuations are quite significant. Okay, and typical height of the boundary layer, it actually varies. It is not a uniform thing or a constant thing that you can define what is the height of the boundary layer. If someone asks you what is the height of the boundary layer, you will not have a one answer to that. Okay, because it depends on various factors. For example, what I have said, it depends based on the roughness element at the first. Okay, so what kind of, where you want to define the boundary layer, it depends on the roughness element in that particular location. Okay, so because if you are considering of the flat terrain, the boundary layer may be small. If you're going for a very rough terrain, the boundary layer may be large. Okay, and again, the boundary layer also varies with the season. If you are talking about the summer time, if you're talking about the winter time, they also vary because of the temperature or solar radiation received by the Earth's surface. And how does that solar radiation changes the boundary layer? Because we have seen that the solar radiation helps the formation or generation of the wind, and also try to make the wind blow in a certain speed. Okay, so if you have higher solar radiation received, so large mass of the wind goes to the upper layer of the atmosphere, and then they starts to have that water cycle and other type of phenomenon which contributes to the change in the boundary layer also. Okay, so that is what I want to say is boundary layer in general, defining a boundary layer thickness or up to what height is the boundary layer, it is very I mean, there is no one answer to that, but in a broader way, you can say that it varies from of the order of 1 to 5 kilometer. Okay, and during the daytime or in the summertime, and in the night, the boundary layer can shrink to few meters, sorry, few hundred meters. Okay, not few meters, few hundreds of meters. Okay, maybe 200 meters or 300 meters in the night time, because the atmosphere is more stabilized in the night because of the lesser solar heating. Okay, so in the daytime, the boundary layer is larger, of the order of 1 kilometer to 5 kilometer, and in the night time, it is around 100 meters. Okay. And of course, above the boundary layer, you have atmosphere, free atmosphere, where your viscous effects are not seen. Okay, and in the free atmosphere also we have previously studied. You can actually get a very well balance between your horizontal pressure gradient as well as your Coriolis force, and that will give rise to your geostropic wind. Okay, so in free atmosphere you get geostropic wind, but in the boundary layer you don't get geostropic wind because you have friction effect in it. All right. Then one of the simplest way you can identify what is the thickness of the boundary layer. Some of you might have also seen this when you travel in the plane. You might see that at certain height, all these clouds are gathered. Okay, so at certain height when you're traveling in the plane, you might see that at certain height, all these clouds will be floating there. Okay, so the boundary layer is actually ends in that location. Okay, so generally where you see the cloud formation, so at that particular height, the boundary layer actually ends. Okay, so that is one of the way to judge the boundary layer thickness. And I think we discussed previously, there are a few devices which measures the height of this cloud from the Earth's surface. Okay, for example, the weather balloon. Okay, there are many other devices. Some we have discussed. So from that measurement, you can also gauge what is the boundary layer in a particular location. All right. So next, yeah, so the difference between atmospheric boundary layer or boundary layer and the free atmosphere, what are the difference? The primary difference are in the boundary layer, you have lot of turbulent wind condition as it is expected, because you have larger roughness element and industrial settings or urban settings. So because of this rough, yes.
I have a doubt. Sir, in the
Yes.
previous slide, you said that the boundary layer thickness is different during the day and during the night. Why is it
Yes.
so?
Yeah, we will come to that. I have a detailed discussion of that. So basically, the broader thing is the solar heating is different during the daytime and the nighttime. Nighttime you don't get sun. Okay, in a particular region, when we define the boundary layer, we focus in a particular region. So in a daytime, that particular location receive lot amount of heat, which will basically because of the heating of the air, what happens? A large mass of the air move up. Okay, so amount of the vertical fluctuation is increased. You can imagine that, right? When you heat up something, what happens when you boil water? You start to see a lot of evaporation. Okay, something similar way you can imagine when you heat up the air because of the solar radiation, air tries to move up and gradually it gets cooled. So the amount of this vertical fluctuation is large. All right, but in the night time you don't expect that sort of or that magnitude of vertical fluctuation. So because of that you get a lesser boundary layer thickness. Okay, so but I have subsequent discussion on that.
Excuse me, sir,
Yes.
I didn't get that point in which you said that boundary height is approximately the height at which clouds are formed.
So this is like again it is a pattern of your what do you call water cycle. When you see that when the air move up, okay, when the air is moving up, it actually captures moisture along with it. So after a certain height, it cannot move further. Okay, so it is so dense that it cannot move further. So that vertical fluctuation which I just spoke, so that ends in this particular region, beyond which there is no significant vertical fluctuation. Okay, so that's why you start to see the cloud formation happen in that particular height. Okay, where your fluctuation dies down and the clouds are stabilized there. Okay.
And this height varies with like day and night time also.
It will vary with the day and night. It will vary with the seasonal condition also. Okay, in a stormy situation and in a calm situation, it will vary. Okay. Okay, so the difference between the boundary layer and the free atmosphere, what are the wind condition basically we're talking here. So the wind is very turbulent inside the boundary layer, and wind like already you know about this because of the presence of lot of surface roughness elements. Wind is turbulent, and that happens because the free stream or the incoming wind speed, it breaks down to a lot of small scale eddies, small and large scale eddies, which is generally called as the turbulent eddies. So due to that, you get a lot of circulation, atmospheric circulation in this boundary layer. All right. So the wind is generally turbulent. You have stronger frictional effect. Yes, that is obvious. And with more rapid dispersion of the pollutants. Okay. So here, since you have a lot of atmospheric circulation happening in this region, so the pollutants, which you get from the industries, or for example, pollens sometimes. Okay, so they can be mixed well in the atmospheric boundary layer. Okay, because you have a lot many small scale, large scale ADs present in this ABL. So therefore there is a rapid dispersion of the pollutant is possible. Whereas if you go to the pre-atmosphere, it will be just carried away. There will not be any significant dispersion. The whole pollutant may be carried away by the air. Okay, but here you can get a lot of dispersion. And another thing is there is no geostropic wind, like I have already discussed, because you cannot get a balance between the pressure gradient force and the Coriolis force as such in the atmospheric boundary layer. Rather, we have also seen that in the boundary layer, the wind tries to curl towards the low pressure region. If you remember, we talked about the Ekman spiral, okay, in the previous chapter. So wind tries to actually spiral near the surface. Okay, it is not a uniform growth, it's rather a spiraling growth. Okay, so there is no geostropic wind condition here. Okay, so there is no balance between the horizontal force and the Coriolis force, but the frictional effects are so dominant. But in the free atmosphere, you get geostropic wind. There is a proper balance between the pressure and the Coriolis force. Okay, and significant of the ABL. Why we need to study about ABL? Because most of the time we spend in the ABL, unless you fly during the time when you just take flights, you are out of the atmospheric boundary layer. Otherwise, you spend your whole life inside the boundary layer. So it is good to know what is happening in the boundary layer. So whatever wind condition you experience, cyclonic wind condition, storms, or in a normal day, if you are feeling comfortable in a particular day because of the certain type of wind, the other day it is very calm situation. So everything is there in this atmospheric boundary layer. Okay, so that is why it is another significant to study about it. Pollution is trapped. So these days we also will be seeing about this pollution, air pollution model. Basically, the emanates from the chimney. Okay, so in that case, how this pollution is actually dispersed in the atmosphere that is also affected by the boundary layer. Fog and forest, these are also formed only in the atmospheric boundary layer. You don't see these outside because of the moisture content in the wind, I said already. And some aviation seepings, few like small jets, you can find that they fly in the atmospheric boundary layer. And crops basically grow in the atmospheric boundary layer, which help you to get food. So dispersion of the pollen become important. If you know study about the atmospheric boundary layer, you can see how basically you can improve your vegetation later on. Okay, so I have highlighted these in the red because this corresponds to the economic of the country also. Okay. Thunderstorm, hurricane situation, these also can be evaluated if you study the atmospheric boundary. So there are several things that can be studied, but we will not go to the details because this will be more than a meteorological study. So just to give you a brief idea, what is the significance of the atmospheric boundary? Okay, then atmospheric boundary layer thickness, like already I have discussed about this. It is it is not a unique term, you can say. It depends on various factors, and it varies from both in the space and time. If you change from one location to the other location, as well as if you measure now or sometimes later, the atmospheric boundary layer can be significantly different also, or may not be so. Okay, if the spatially if you are not changing a lot, the roughness element remains the same, then the boundary layer may be same, may not be significantly changing. Okay, so generally in the daytime it is 1 to 2 kilometers, in the night it is few hundred meters. All right. Okay, then the characteristics of the atmospheric boundary layer, if we talk about some quantification, so you can quantify the wind condition in the atmospheric boundary layer in three ways. Like these are the three constituents of the wind in the atmospheric boundary layer: your mean wind speed, then the turbulence of the fluctuating wind, and the waves. Okay, so these three together, whatever wind speed you see, the wind condition you see in the atmosphere, basically they are constituent of these three. So here I have shown them separately. Okay, this is the mean wind condition. You generally see that the mean wind stays more or less same. If it is increasing, it will not be changing as significantly. If it is rather, it will stay more or less same, or a horizontal line with the time. Okay, there could be some wave waviness in the wind. Okay, that may come from various atmospheric circulation, and they may be periodic or aperiodic. Okay, so this is separately shown here in the waveform, the periodic waves, and the fluctuation, the small scale fluctuations can appear because of the several industrial settings, or even these urban areas also, they may leads to small scale eddy formation. Okay, so all these three together will give you the wind speed in a particular region. Okay, now the thing is, you can separately segregate them and study. You can find out what is the mean component, what is the waviness component, and what is the turbulence component in a particular wind data, measured wind data, or can so that will be easier. In general, we do in that way. We separate them and try to, whatever prediction we do, try to do on the mean wind condition, or when you are interested for the turbulence intensity in a particular location, you try to just investigate the fluctuating part. Okay, and then waviness, for few applications also waviness is important. So they can be studied separately. That is what I want to say. Then another thing is, in horizontal wind condition, basically when you are trying to see about in a horizontal variation of the wind, these will be dominated by your mean flow or your waviness up to a certain extent. Okay, so whatever variation in the heat, momentum, moisture, or the pollutant in a horizontal manner, okay, in a plane, xy plane, if you're talking about, then it will be mostly due to the mean wind. And if there is dispersion in the vertical direction, all this like heat, momentum, moisture dispersion in the vertical direction, that generally happens because of the turbulence. Okay, so the changes in the horizontal direction is because of the mean wind, changes in the vertical direction is because of the turbulence. All right, so okay, it's okay, let me quickly finish this one. So now, since I think this is a recap for you already, you might have seen this in the previous lecture also, and might have studied earlier. So the fluctuating and the mean component, they can be shown in this manner. Like if u is your instantaneous velocity, so you can have a mean wind condition as well as your fluctuating part. Okay, so in this mean, actually you can have your waviness also included in that. Okay, so mean and the fluctuating part. Then how do you get the averaging? Like there are different ways to take the averaging. So if it is a continuous function, you can simply integrate it, or if it is a discrete data, like generally we get the discrete data, then you need to do the summation and summation over the total number of points. Okay, discrete data set. So this can be done temporally or spatially. Okay, so if you're talking about this integration or the summation over the time, okay, they have different interval, let's say 1 minute interval. Now then after 1 minute done. So if the data sets are obtained after 1 minute interval at a particular location, okay, you are not changing in the space, just you are keeping the space constant and changing over time, and you can get the averaging of that. That will be a temporal average. Similarly, if you are fixing your time, changing the space, like at a particular time you are measuring it at different locations, so average of that will give you a spatial averaging. Okay, now if the turbulence is same, okay, if these values do not change over time, or it do not change, or rather you can think in this way, if the turbulence doesn't change with time and space, it will be called as your homogeneous turbulence. Okay, so if the turbulence is homogeneous, then you may get these two data to be same, or these average terms to be equal, right? Now, so these quantities are important because there could be several derived quantities. Like mostly in aerodynamics, we see different quantitative figures, right? So those you can derive using this kind of averaging. All right. So one of the example here is okay. So there are few averaging procedure, like this is also probably you have studied. If you take average of the fluctuating component, it will be 0, right? So if you sum them together, all the fluctuating component, you will get 0. Then if you take product of u and c, c is a constant times your u velocity or their instantaneous velocity. If you just multiply with a constant, then the outcome is c times u bar. So u bar is your average. Similarly, if you try to add two velocities u and v, then take average of that instantaneous velocities, which has both fluctuating as well as this part, mean part. Then you will at the end you will get u bar and v bar. Okay. Similarly, if there is another one like multiplication of u bar, average of u, and instantaneous v, then you get this, and derivative of this. The partial derivative of del u by del t, if you take average of that, you'll get this. So this simplification you can try out on your own, and you see that this is not very difficult to follow. Okay. So try these two on your own, uv bar and u square, where u and v both are your instantaneous value. So that means it has both mean and fluctuating part. If you take the average of that, what is the data? And if you take average of u square, like multiplication of u and u, what is the value you'll get? So let's discuss this tomorrow when we start our class. It's already going to be 1. So I stop here today. Any question?
Excuse me, sir.
Yes.
Sir, in the fourth one, it is like u fluctuation multiplied by v, and we have taken mean of it, or it is u mean.
This one.
Yes, sir.
This one. Okay. So this is u mean.
Okay.
Already u mean. You can see here. Okay. Okay. So let me take the attendance. Okay. Okay. Okay then. See you tomorrow. Bye bye.